A plasma is composed of electrons and ions. The ions can have a wide variety of energies. What we mean by plasma ion control is restricting that ion energy to a relatively small range for a particular application. Ion energy and plasma control is critical in both PVD and CVD processes. In PVD, energetic ions will sputter any material. The higher the energy, the more damage they will do to the substrate. Likewise, for low energy ions, you can densify a film instead of sputtering it. For CVD, on the other hand, all the film properties are entirely dictated by the energy of the ions. Denton has a number of patents related to ion energy control, including for ion-assisted deposition in E-beam, ion beam etch, ion beam deposition, and our PIB-CVD technology, as well as a staff of process and research engineers who are actively developing this technology. Ion energy is the energy of each individual ion in the ion source, and ion current density is the total number of ions you're producing per unit time. Most sources can produce some tunability of these properties, sometimes over several hundreds of electron volts, but only Denton has technology that from the same source can produce high current density for both very low 25 eV ions as well as very high 500 eV ions. Going back to our PIB-CVD technology, using a single precursor, HMDSO, this is commonly used for producing diamond-like carbon. With our technology, we're actually able to produce, at high flux, low energy, we're able to produce a polymer-like film. And then simply by changing the ion energy, we're also able to put on top of that a diamond-like composite, DLC-like film. So from one precursor, simply by changing the ion energy, you're able to get two completely different films. One very polymer and soft, polymer-like, and one hard and diamond-like. Since the only thing we're changing as we go from low energy to high energy are gas flows and power supply settings, this is completely compatible with automation software and is controlled by our Process Pro platform technology. This provides full recipe control that can be individualized for each wafer. We have a number of customers using our Endeavor for ion-assisted E-beam deposition. Conventionally, this is done with end-hall sources. However, end-hall sources have a wide distribution of ion energy, including high-energy ions. This is fine for most oxide films. However, this customer wants to deposit fluoride films, which are a bit more delicate. So typically you do not use ion-assisted deposition with this, or the fluoride compounds will break down. With the Endeavor, we're able to go to very low ion energy and give just a gentle assist, and we're actually able to do ion-assisted deposition of fluoride compounds. Another example using an Endeavor is stress control. Because we have such good control over the ion energy, we're actually able to tune the stress of the optical films. This enables you to compensate stress and end up with a net zero stress film. And we've demonstrated this by putting it on an optical filter on a piece of plastic sheet, and then we're able to get it to not curl up due to stress. Going back to the PIB-CVD technology, as I mentioned, we're able to put down a polymer-like film at low energy and a diamond-like carbon film at high energy. Additionally, all the energy is coming from the ion source. None of it is, no extra energy is required, so you don't need any heat, you don't need any extra plasma assist. So you can do this at room temperature, which means you can put, by building up a gradient, a soft adhesion layer down on plastic, and very quickly put a diamond-like composite layer, a DLC film, on a plastic substrate. You can also make it a diamond-like nanocomposite and make it optically clear. So we can put an optically clear, very hard film on plastics. I also haven't discussed our Biased Target Substrate technology. Using this technology, you're actually able to control the ion energy only at the source of a sputtering target, and that eliminates contamination. So we have customers using this technology to put down contamination-free, the purest possible optical films using this technology.